AMC 10A 2022, problem 22. We want to work on this problem and the background idea of this one, and also I leave homework. It says suppose that 13 cards numbered, suppose that 13 cards numbered 1 to 13 are arranged in a row. Task is to pick them up in numerically increasing order, working repeatedly from left to right. In the example below, cards 1, 2, 3 are picked up on the first pass. Look, 1, 2, 3, because 2 is on right side of 1, 3 on right side of 3, so first pass. So let me write first 1, 1, 1. Now in second pass, you say, okay, 4 is here, 5 is here. Okay, because 6 is on left side. Third pass, 6. 7 is on left side of 6, so in next pass 4, 7, 8, 9, 10. Now 11, 11, 12, 13. So we have 5 passes. And it explains here for how many of the 13 factorial possible orderings of the cards will the 13 cards be picked up in the exactly 2 passes. So before solving this problem, let me tell you an idea. Idea 1, when something is before something, for example, an object is before the other element or another object. So we have an idea. For these types of problem, we have 2 steps. Let me tell you first some problems, then we will complete this idea. Okay, so for example, suppose we want to see how many arrangements or permutations are there. How many arrangements are there such that from what to what, for example, part A, from 1, 2, 3, such that 1 is before 2. An easy problem. Try this one first on your own. Okay, for this one, we can say 1 is, you can draw the diagram 1 before 2. So 3, because we have 2 parts, you say, okay, for example, 3, you say 3, choose 1. Then for 1 and 2, we have 1 case of 3. Because it is easy, it has lots of other solutions. Let's try a bit harder. For example, suppose we have 1, 2, 3, 4, 5, and 1 is before 2, and 2 is before 3. Or let me tell you, 1 is before 3. So try this one first on your own. So if we draw for this one the diagram, it will be what? 1 is before 2, is before 3, 4, 5. So how many parts are there? 3 parts. So the idea for these types of problem, the rest of ideal one. Yeah, it has 2 steps. First step, if we have more than one part, solve part by part. 2, if there is one part, then uh, focus or consider. Let's consider the most, for example, consider the most limited element. So here we have 3 parts, so let's solve part by part. So for 5, we have 5 positions, 5 is one part. You say 5, choose 1 for 5. Then we place 5. Without loss of generality, for example, 5 is here. Then for 4, we say 4, choose 1. Without loss of generality, we consider 4 is here. Then for 1, 2, 3, we have one part. The most limited element is 1, 1. 1, and you can erase. You can say, okay, 4, 5. Now here, the most limited element is 1. We place 1. We have to place 1 in first position in these 3 positions one way. Then 1 is before 2 and 3. You can erase. Then again, we have 2 parts. You say 2 has 2 choose 1 and 3 1 choose 1. So the answer will be what? 5 times 4, 20. 20 times 2, 40. Okay? Now that you've learned this, we have lots of other example to get good at this idea. It's so much important. If you want to learn, if you want to work on more problems, feel free to send message my WhatsApp number in the description. Now that you know this, let me tell you a homework for these types of problems. Suppose that we have 1, 2. Okay, let's consider a part that is hard. Now suppose we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We say 1 is before 2, 1 is before 3, 1 is before 4. Let me tell you, is here 1? Okay, 1 is before 2, 1 is before 3, 1 is before 4, 2 is before 5, 2 is before 6, and 6 is before 7, 8 is before 9, and we have these conditions. Homework 1 is this. Homework 2, for homework 1, you should draw the diagram. For homework 1, I say, okay, 1 is before 2, 3 is before 2, 2 is before 4, 5 is before this, 6 before 5, 7 before this, 4 before 8, 8 before 9, 9 before 10, 11, 12, 13, 14. Okay, how many permutations do we have for 1 to 14 such that we have these conditions? Okay, try these 2 problems as homework. So it was idea 1. Now let me tell you idea 2. For idea 2, we have n choose 0 plus n choose 1 plus n choose 2 to n choose n. It is equal to what? Try first on your own. Okay, because we are considering all subsets with 0 element, with 1 element, 2 elements to n elements. So it will be 2 to the n. Okay? Now we want to use these two ideas to solve the problem. Okay, so okay, and also idea 3 before solving the problem is case. Okay, casework. Casework it's that we consider a property and we consider different cases of that. Let's do it in this case. So it says we need exactly 2 passes. Okay, so we work on first pass. We say okay. We consider cases of first pass. So first pass can be what? First pass, second pass. So first pass can be 1, second pass can be 2, 3 to 13. First pass can be 1, 2, second pass will be 3, 4 to 30. First pass can be 1, 2, 3, and second pass 4, 5 to 13. Okay? And up to the case that first pass is 1 to 12, and second pass is 13. Okay, so we have 12 cases. Now that we have 12 cases, let's consider first one, that the first pass is 1. So first pass is 1. So why 2 is in second pass? Because 1 is before 2. 1 is after 2. Okay? And then because 2, 3, 13, all of them are in second pass, so we can conclude 2 is before 3 by the definition of the problem. 4 to 13. So now we want to use our idea. We had 2 steps. If we have more than one part, solve part by part. If there is one part, consider the most limited element. Now here we have one part. The most limited element is 2. So 2 is the first one, and 1 is what? When we erase 2, then we have 2 parts. 12 elements, 12 choose 1. Okay, so it is 12. Now it was first case. Second case, suppose first pass is 1, 2. So 1 is before 2. Second pass is what? 3 to 13. So 3 is before 4. 4 is before 5 to 13. Because 3 is not in first pass, we understand that 2 is before 3 or 3 before 2. Pause the video and try to find the answer. 3 is before 2. Because if 2 is before 3, then we say, okay, we have one pass. So 3 is before 2. Now let's solve this. For this part, we can say, okay, it will be 1 before 2, 3 before 4, 4 before 5 to 13, minus 1 is before 2, 3 before 4 to 5 to 13. So the bad case is 2 before 13. So it will be what? This one. We have more than one part by using the idea I told you. Is 13, choose 2. Minus this one, 1 before 2 before 3, 13, 1 cases. Okay, now let's try for general case. For some 1, 2, 2. K and K plus 1 to 30. So this one before this. So again, we can say 1, 2, 2. K plus 1 to 13 minus the case of that 1 is before 2. To K is before K plus 1 and K plus 1 to 30. Okay, so it will be what? This one will be, we have 2 parts, 13 choose K and the rest will be unique minus this one 1. Okay, so we can say sigma K from 1 to 12. Sigma means you should consider for each one when you write 13 choose K minus 1. For K1, K2, you write all of them and write addition between them. Okay, some of these elements. And as you can see, the first one also, we can say it is 13 choose 1 minus 1. Okay, which is 12. Now, it will be what if you write all of them, or without sigma also we can write 13 choose 1 minus 1 plus 13 choose 2 minus 1 to 13 choose 12 minus 1. Okay, now if we want to add, if we consider 13 choose 1, 13 choose 2, 13 choose 12, we can use idea 2 here, 2 to the n. Here it will be 2 to the 13, but we don't have 13 choose 0 and 13 choose 13, so we should subtract. And how many ones do we have negative ones? 12. So it will be 2 to the 13 minus 1, minus 1 minus 12. So it will be 2 to the 13 minus 14. is 8192 minus 14. So 12 minus 4 is 8. 8 minus 1, 7. 8178. Okay, so the answer is choice D. Okay. If you here, we've considered two ideas and three ideas. And I told you two homeworks. There are lots of other homeworks. If you want to learn 40, 50 important ideas and formulas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Okay.